I'm Nelson Mills, co-founder and CEO of VATN Systems. First, want to thank Mike and Landon for having us here. I think this is an awesome opportunity to demonstrate our systems. What you see here is a pre-recorded video of our team moving down the beach with a couple vehicles in the back of an old Defender. And what you see here is Josh, our test engineer, live planning through ATAC this same mission. We wanted to do it live, but unfortunately 30 knots of wind does not go well for our UAVs. Our drones are fine though. We've done them in 10-foot seas. But you can see our teams here is hopping out, grabbing the drones, and they're going to walk into the water while Josh plans this mission around the same time. So you can see he's already got the line down. He's sending the mission, and you can actually see live on the map the dots of actual vehicles on the ATAC network. We got Thor and Loki, or Thor and Fish One. We go with the Norse name. So for those who've been asking, VATN is water in Old Norse. But now Ryan here on the video is releasing the two videos at the same time, and you'll see them take a coordinated path, all planned through ATAC, to a fixed waypoint, simulating a potential kinetic strike, deployment of EW sensors, deployment of a variety of non-kinetic effects and sensors. We can do scanning with sonar. We can collect passive acoustic data. We've built a fully modular system with our vehicles to enable them to carry a variety of payloads. Right now they're on the surface. You can see there's a bunch of wake. You can definitely tell they're there visually, though there's no radar signature when on the surface. And then once they dive, you'll see they're very, very difficult to see and detect. Should be diving any second now. So they'll do a brief surface run in order to, yeah, there you go. And they'll dive, and you can see they're turning in a coordinated manner, all headed towards the same endpoint. At VATN, we build not only the hardware, but all the software that enables this, right? The software infrastructure that makes us a true force multiplier for the user. If you need to send a whole bunch of vehicles at a target, one user can mission plan and send that to 10 vehicles, even 100 vehicles, and plan complicated scenarios to enable that. Or if you want to deploy a whole bunch of EW sensors or effects. In actual military exercises, we have deployed GPS jammers, RF jammers, and cyber effects, enabling our customers to deliver stealthily effects on time. So as this video continues, we will see them. You can just see the shadow of the other one there, and you'll see them connect and continue along the same path, and then they'll pop up basically within less than 2 meters of each other. And you know, this is real life. VATN Systems is delivering vehicles to U.S. government customers. We are active in exercises. And we are, excited to continue build and ramp up our production rates. So we'll be announcing soon a new factory online, which will be a major improvement on the current state of the production of underwater vehicles and torpedoes. And our opinion is that one of the greatest national security threats right now is our inability to have a platform manufacturer of underwater vehicles and torpedoes in the United States. And so we see ourselves as a key measure in filling that gap. Our vehicles cost up to 10x less than existing options. The S6 vehicle you see here, it's a 6-inch diameter, 5-foot-long vehicle that starts at about $75,000. Depending on the payload you get, it can stay there or range a little higher. as you can see here, fully integrated into ATAC, but we are ultimately networking and comms agnostic, right? If you want RF on there, if you want acoustic comms, it's really the choice of the customer. We're trying to make this as open and as collaborative a platform as possible. You can launch it from the beach. You can airdrop it. We've dropped it off Chinooks. You can underwater launch it. You can drop it off USVs or auto launch it from USVs, and we'll show another video in a bit of that happening. As you can see, we're reaching the end of the mission. For example, let's say that was a target boat. You could pop up, either veer into them for an intercept or pop up and do an EW effect, or a cyber effect, or just collect data. Or we've also done delivery of high-value payloads where a team at a target pulls out the payload and does something with it. So you wouldn't even be able to see the vehicles if we ran them a little deeper. Unfortunately, submarine races aren't that exciting to watch, so we decided to run it a little closer to the surface so you could actually see what's going on. The great advantage of underwater vehicles, though, is just stealthiness and the difficulty in which other folks have to intercept them. So we'll show now Josh planning a more complicated mission. So, and you can see this is all happening real time. We've trained Marines to do this in minutes. So he's entering speeds, he's entering depths, and he's going to try and infiltrate a port nearby, which is an exact scenario we've done in multiple military exercises. So I think he's actually adding a loitering point. Is it here? Yep. So he's adding a loitering point. So the vehicle would get to the entrance of the port, it'd be able to loiter, so he can add that constraint. And then via satellite RF or acoustic comms, a commander could give it a no-go or a go or no-go. If it gets no alternative commands, it will go in and do its mission. In this case, a simulated kinetic strike. So it allows commanders to deploy assets into an area, and then if they want to make a decision to bring it back or not, they can. Or it can just proceed fully autonomously to accomplish its mission. Nothing we do here is with active control. Everything's fully autonomous and working fully on its own. So, and now let's say you're worried about an enemy or adversary pulling the vehicle out of the water or going off course, and you need to scuttle it. Josh can now add a set of constraints. So he's adding geofencing. So if the vehicle detours outside of that path, it will automatically scuttle. And you can see how quickly he's building this whole complicated mission plan. He can also add time constraints to scuttle. There's a variety of things that we're kind of just tip of the spear here. And we've trained Marines and other folks in a very brief amount of time to build these complicated plans and deploy them with 20 to 30 minutes of training. And that's where VATN becomes a true force multiplier. We're upending the ratio of people to drones. Your typical underwater drones, it's a whole team to plan. And now we're looking at one person or a small team planning for tens, hundreds, if not thousands. And then the great thing too is we're not beholden necessarily just to ATAC. We can do fully autonomous launches. So we look at this video here at a Silent Swarm last year. We launched off of a USV completely autonomously. You can see our vehicle launched and then went off and did its mission. So we can take targeting data from USVs and automatically mission plan with no human intervention to go and gather data on a target, strike a target, deliver electronic warfare effects, whatever you want to do. And you can swap those different payloads completely without tools. So this is this VATN ScaleMirror S6. Appreciate your time, and if you have any questions, feel free to reach out. Thank you.